Okay, so they've done implicit differentiation to us a few times, and we've had product rule in it, but this is the first time they've brought out the quotient rule. So it won't change a whole lot, but it's going to take a little extra time and space. One piece at a time. The derivative of 3y is 3y to the 0 dy minus, and now we get into the quotient rule. I'll try to fit it all in there. The quotient rule, you remember, goes bottom d top minus top d bottom over bottom squared. So that means bottom, x squared. D top, the derivative of the top would be 4y to the third dy. So bottom d top minus top d bottom. The derivative of the bottom is 2x dx all over the bottom squared. That'll be x to the 4. So this is the derivative of 3y. This is the derivative of y to the 4th over x squared. And now over here we have the derivative of 2y, which is simply 2 dy. Now, if we divide the whole thing by dx, here we get dy dx. Here we get dy dx. That dx just cancels, and here we get dy dx. I don't like having this trapped inside a fraction like this. I'm going to split this fraction into two terms in the next line because we need to be able to move things around freely. So this is mostly a cleanup line. 3 dy dx minus, we have 4 x squared y to the third. 4x squared y cubed dy dx. And this is over x to the 4th. I'll be simplifying those powers of x in a minute. I didn't notice it in time, so for now I'll just leave it. But so we have this negative sign for x to the 2, y to the 3, dy dx over x to the 4th. That's our first term in here. Now we have this one, which is, we have a minus out front times another minus here, so this next term is actually positive. It contains a 2. It contains x and y to the 4th. No d this time, its dx got cancelled out, and it too is over x to the 4th. And on the right side we have 2 dy dx. Big eventful line, but now that we have everything spiffed up, what comes next will be easier. Remember, we want to get all of our dy dx's into one group, and all our terms, in this case our one term that doesn't contain dy dx by itself. So I'm going to take this 2 dy dx over to the left. I'm going to move the term without dy dx over to the right. And that gives us 3 dy dx minus 4y cubed over x squared. See what I did there? I had x to the 2 over x to the 4. I divided the top and bottom by x squared. So now this is a little leaner. And we get minus 2 dy dx. So we moved it over to the left side. And this term moves to the right side and becomes minus 2. The x, or one of the x's cancels. So we're left with y to the 4 over x to the 3, if I'm not mistaken. Okay, so we have all our dy dx's on the left, the term without dy dx on the right. We have 3 instances of dy dx, but that's easily fixed by factoring. And that gives us 3 minus 4y cubed over x squared minus 2. No, I can't leave that alone. 3 minus 2. I'm just going to change this to a 1. That's much nicer. Okay, so 3 here minus 2 here ends up being 1. This term does not change. And on the right side, we have minus 2y to the 4 over x to the 3. if we want to solve this for dy dx, we divide both sides by that term, and dy dx equals minus 2y to the fourth over x cubed divided by 1 minus 4y cubed over x squared. We could clean this up tremendously if we got a common denominator here and then multiplied by the reciprocal. Let's do it. I shouldn't just claim that and then not follow through. 2y to the fourth over x cubed over, this 1 is x squared over x squared. So if we do that, our denominator is x squared over x squared. That's our 1 minus 4y cubed over x squared. Now that we have that, instead of dividing by x squared minus 4y cubed over x squared, I'm going to multiply by the reciprocal of it. So we get minus 2y to the fourth over x cubed times x squared over x squared minus 4y cubed. Does that help us? Well, a little bit. I can cancel x squared, and I can cancel 2 of the x's there. And so if we do that and combine it all into one expression, we get minus 2y to the fourth over, and I'm going to multiply these together, x cubed minus 4xy cubed. Is that better? Yeah, a little. Was it worth it? I'm not sure, but this or this would be an accurate derivative.